An occasional chair like this is handy to have whenever you've got extra guests for parties or over the holidays, but this chair is special. It articulates into a 4-step step stool. Now you can buy a cheap step stool anywhere, but I challenge you to find one in any store that looks this good. And you're a woodworker, why would you need to? It's a fun project to build. It also doesn't take a lot of wood, so here's a perfect opportunity to use some special stock you have on hand. I used ribbon stripe mahogany for the vertical parts and quarter sawn padauk for the horizontal parts, and I think it turned out pretty sharp. It's another classic project plan from Woodworkers Journal's archives, and it ran in our magazine back in 1992, but I think it's just as functional today as it was then. Now you can find that original article linked to this customizing for the gridded drawings and material list, but we've expanded the step-by-step instructions here to give you even more information. And in this video, I'll show you how to build it every step of the way. So without further ado, here's how to make one. Now to get this project underway, the first thing to do is to glue up a couple of large panels for the upper and lower pieces. I made my panels 4 feet long and 13 inches wide so I could fit one upper piece and one lower piece on each panel, plus have a little extra room for machining. Then it was off to a photocopier to enlarge the gridded drawings that come on the classic plans that are linked to this customizing. And here's a couple of tips for the photocopying process. Start with the original and enlarge that to 105% to make oversized copies of the grids. Then cut those up into several pieces and enlarge those 200%. And that will bring you up to the 1 by 1 inch square grid pattern that you need. Tape those grids together to make one giant pattern, and you're all set to go. Apply spray mount glue to the back of your taped up full-size pattern, lay it down on one of your panels and roll it smooth. If there are any loose edges between the sheets of paper in your pattern, tape them down securely with clear packing tape. With your pattern in place, you're all set to start the machining process. And the best thing to do first is to route the dados for the first and third steps and for the spline slot that runs along the lower pieces. Now the reason why you should do the dadoing first is your panel is still at full size, so there's plenty of bearing support for your router. It's much easier to do that now than when you've got these work pieces cut to smaller proportions. There's a lot of different ways to route dados, but the challenge to doing these dados is they're set at a 70-degree angle on the work pieces. They're not square in relation to the panel, so you can't use the edge of the panel as a reference edge. The way we're going to do it is to use a slotted jig like this. It's simply 2 pieces of 1/4 inch plywood that are spaced apart the same distance as the outside diameter of a guide collar that I'm going to have installed on my router. I'm going to use a 1 inch outside diameter guide collar and a 3/4 inch straight bit to route the dados. Now, the guides on my jig are attached to one another with 2 cross pieces, top and bottom, and I've applied some sandpaper to the bottom of my jig with spray mount glue to hold the jig in place once I've positioned it. The beauty of a jig like this is you can route dados at any angle. They don't have to be square in relation to your panel, so once you've got it positioned the way you wanted and clamped in place, you can simply set your router in the slot and run it across to route your dados. It's foolproof. You don't have to worry about running your router against a straight edge. You don't have to worry about your dados veering off course. You'll get arrow straight dados every time. The important thing on this jig is to make sure that the slot exactly matches the outside diameter of your rub collar, and that way you'll have no side-to-side play when you use the jig. Draw reference lines to extend the dados on the pattern out to both edges of the panel. This will help in setting the slot cutting jig more accurately. Use a sliding T-bevel gauge locked to the correct angles to draw the lines. A long rule held against the T-bevel can help extend the lines accurately to the opposite edge of the panel. Set the slotted jig carefully into position so the dado reference lines are evenly spaced inside the jig's slot. Clamp the jig down securely against the panel and to your workbench. Otherwise, if it happens to shift during routing, cutting accuracy will be lost. Install a 3/4 inch diameter straight bit and a 1 inch outside diameter guide collar in your router. Adjust the cutting depth of your router to about 1/8 inch, set the guide collar in the jig slot, and push the router across the panel to make the first spline cut. Once you've made the first pass, reset the cutting depth and make a second pass to deepen the spline dado to 1/4 inch. Repeat this process to route dados for the first and third steps in the upper and lower side pieces. It helps to mark the slot cutting jig with a reference line to show you where to stop the router's base for each of these 2 dado cuts, since the router will mostly cover up the cutting path. Cut the step dados 1/4 inch deep to match the spline dado. Once the dados are cut, head to your drill press to drill out the curved corners of the cutout shapes in the side pieces. You can use a 1 inch diameter Forstner bit for most of these curves, but 1 or 2 will require a 3/4 inch bit instead. Drilling out these corners will ensure nice, smooth curves and make the jigsawing process easier. When all the corners are drilled out, use a sharp blade in your jigsaw to remove the rest of the waste for the inside cutouts. Cut just inside the pattern layout lines so you can sand the cutouts further to refine their shapes. Now go ahead and cut out the upper and lower sides. Use a jigsaw for the curved cuts, but switch to a circular saw guided by a straight edge for making the straight cuts for best results. Or run your jigsaw's base against a straight edge to help control the cuts. Smooth all of the saw cuts up to the pattern lines using an oscillating spindle sander or sanding drums in a drill press. For the broad curves, use a large diameter drum instead of a smaller one to help reduce the ripples in your sanding process. When your first upper and lower side pieces are ready, set them on the second panel and trace their shapes to form the other pair of upper and lower side pieces. While you're at it, carefully transfer the spline and step dado locations onto the second part shapes so you can use them as references for setting these dados to match. Adjust your T-bevel gauge to the angles of the dados on the first workpieces and transfer these angles to the second set of workpieces. With the dados located and marked, now you can cut the second upper and lower side workpieces to rough shape, leaving at least 1/16 inch of material outside your layout lines. Then clamp the slotted jig in place to route the spline and step dados. Double check your accuracy before turning on the router. These dados must match their counterparts on the other workpieces almost perfectly. After cutting the dados, make a couple of short filler pieces from 1/2 inch thick scrap to fit the dado slots. This way, you can register each pair of upper and lower side pieces together for template routing the parts to match. Assemble the pieces with the filler strips installed and use some double-sided tape to hold them together. Next, head to your router table and template route the upper and lower side pieces to match the first set you made. Depending on the grain pattern of the wood you're using for this project, you may need to switch from a flush trim bit with the bearing on top to a pattern bit with the bearing on the bottom, and flip the work pieces over to route some of the curved areas. The goal is to avoid routing against the grain pattern, which can lead to tear out. Plan your routing process carefully before you begin. Separate the upper and lower side pieces after the routing is completed. Now, cut 2 1/4 inch thick splines for the lower side pieces and glue and clamp them into place. When the glue dries, trim the splines flush with the edges of the lower sides. This is a good time to ease the sharp edges of the upper and lower sides by rounding them over. We used a 1/4 inch roundover bit in a trim router for this operation. Remember to route clockwise for the inside cutouts and counterclockwise for the outer edges to avoid making climb cuts. Set your side pieces aside for the moment and joint and plane stock for the back, stretcher, 4 steps, and seat. Rip and cross-cut these parts to size. If you haven't done so already, enlarge the gridded patterns for the chair back and stretcher to full size. Use spray adhesive to stick them in place on their workpieces and roll the pattern smooth. Then step over to your drill press to drill the ends of the handle cutout on the chair back with a 1 inch diameter Forstner bit. Hold this workpiece against a clamped fence when drilling these 2 holes to keep them aligned. Cut out the waste piece in between with your jigsaw to open up the handle shape. You can proceed to cut out the back and stretcher workpieces now and sand their edges smooth on a spindle sander or with sanding drums. The back edges of the first and third steps need to be bull-nosed in order to fit into the curved ends of the dados and the side pieces. This is easy to do with a couple of passes against a 3/8" radius roundover bit in the router table. Now sand the back, stretcher, steps, and sides up through the grits to 180. Make sure the curves and transitions are nice and smooth. Then slip the first and third steps into their dados, clamp the parts temporarily, and mark any overhang where the steps protrude past the sides. Tilt your table saw blade to match these angles. It should be about 20 degrees, and trim the steps to final width. While you're at it, the inside edge of the top step also needs to be cut to this angle. At this point, you're ready for some assembly. Start by installing the back between the upper sides. Clamp it in place about 2 inches below the top ends of the upper sides and center it front to back. Trace around the back's 4 points of contact with the sides. These will be your only references for positioning the assembly screws. Then unclamp the parts and drill centered 1/8" pilot holes through the sides at each of the 4 traced references. Reassemble the back and sides and use these pilot holes for drilling deep counterbore screw holes through from the outside faces of the sides and into the back. Drive 1.5" flathead wood screws into each of these holes to attach the back. Add the third step next. Spread glue in the dados before slipping the step into place and driving screws through the upper sides to secure it. Then fasten the seat and top step workpieces to the upper sides with more 1.5" wood screws driven into counterboard pilot holes to complete this assembly. Now move on to the lower assembly. Bring the lower sides together with the first step using glue and counterboard 1.5" screws to secure it in its dados. Add the second step, gluing and screwing it down to the top of the lower assembly. Complete this sub-assembly by fitting the stretcher into place between the sides and attaching it with more counterboard screws. All of the exposed screw heads need to be hidden under wood plugs, so make those next. It's easy to do with a plug cutter at the drill press. Make the wood plugs from a piece of scrap left over from your project wood. For safety, hold the workpiece against a clamped fence to immobilize it when cutting the plugs. Install the wood plugs with glue and trim them flush with a flush cut saw, a chisel, or an oscillating tool after the glue dries. Sand the plugs smooth. With your wood plugs sanded flush, you're just about ready for finishing, but there's still one more step to do. Now is a good time to install the piano hinge and check the fit of the parts. Cut a 15" length of piano hinge and install it so the edges of the hinge leaves are flush with the top and bottom faces of the 2 seat boards. Now, one thing to keep in mind when you're cutting piano hinge, don't just measure from the end of the hinge and lop off 15 inches. What typically happens is the endmost holes of the hinge you make won't line up evenly with the ends of the hinge. The better thing to do is to balance that 15 inches out over the 2 end holes and make 2 cuts instead so that your hinge looks balanced. Then install the hinge with 4 to 6 screws and stand the project up. And what you want to see is that your seat board is nice and flat in the chair mode, and that all 6 points of contact are touching the work surface in the step stool mode. If anything's a little bit out of register, now is a good time to sand the bottoms of all the feet and the top ends of the chair until everything stands just right. Then you can take the hinge back off and you're all set for finishing. And as far as finishing goes, I'm using an oil varnish blend, which I think is really popping the figure nicely on that ribbon stripe mahogany. This has been a fun project to build, and I think it's going to be real handy to have around the house. I hope you decide to build one of these convertible chair step stools for your home too, and thanks for watching.